everyone, welcome to my video, and today I will be giving a very detailed explanation on Euler method. So Euler method basically gives an approximate answer by iteratively updating the solution at discrete points in the domain, giving a rough estimation rather than an exact solution. So for example, I'll be having dy over dx is equals to y, where y bracket 0 will be equals to 1, and as I solve the equation, I will get y is equals to e to the power of x. Then I form three variables, which is x, y, dy over dx. If I give h the step size as equals to 1, the x will be increasing by 1 each time I substitute in the table. And y is equals to e to the power of x, so when x is equals to 0, y will be equals to 1. If I assume that the gradient is constant, dy over dx is equals to y, and dy over dx will be equals to 1. For subsequent steps, I can apply Euler's method, which when x increases to 1, y will be the previous y plus the h multiplied by dy over dx, which is equals to 1 plus 1 times 1, to give me 2. And since dy over dx is equals to y, the next value will be equals to 2. And as I continue down using the Euler's method, these are the values that I got. With these values, I can plot out a graph. From here, you can see that Euler's method actually gives an approximate curve that is close to the actual curve of y is equals to e to the power of x. It also shows that Euler method actually gives the approximate values and answers to help us solve the solutions. So now I'll be using Excel sheet to help us to solve the IVP. This is the Euler formula. And we're given that dy over dx is equals to x over y squared, and that when x is equals to 0, y is equals to 1. And we're supposed to find the approximate value of y when x is equals to 1. So I created three columns. There's x, y, function f x, y, which is equals to dy over dx. And I put in x is equals to 0, y is equals to 1. Function f x, y is equals to x divided by y squared, according to the formula, which gives us 0. The step size of h is equals to 0.1 because a smaller step size will give a more accurate approximation of the solution. Hence, the next value of x will be equals to initial value plus 0.1, which gives us 0.1. And y, according to Euler formula, will be equals to the previous value of y plus the step size multiplied by the previous value of function xy to give us 1. And the new value of function xy will be equal to the new value of x divided by the new value of y squared, which gives us 0.1. And with the help of Excel sheet, as I go down, I'll be able to get all the values of x and all the values of y and function xy. This will be the final value that I want for y. So now I'll be finding the value of y when x is equals to 1 via the first ODE. As I integrate this equation, I will get y is equals to cube root of 3x squared over 2 plus c. And I use x is equals to 0, y is equals to 1 to find c is equals to 1. And after that, I find the exact solution of y is equals to 1.3572. Since the exact solution that we get is 1.3572, we'll compare it with the previous solution that we get from Euler's method, and the approximate error will be the exact solution minus the previous solution that we get, which is equals to 0.017885. If I reduce the step size from 0.1 to 0.05, I'll get the value that's very close to the exact solution, with an approximate error of 0.008747. Hence, from this we can see that Euler method only provides solution with an accuracy limited to the step size chosen. And the smaller the step size, the more iteration and calculation is required to find the solution, which is more tedious. And this problem can be solved with the correct use of Excel functions and formulas, which can efficiently help to reduce the computational time. And this is how we can use the Excel spreadsheet to help us to solve the IVP. Thank you for watching my video.